Hello students, welcome to the lecture on object-oriented database, and after this lecture we will be able to learn the following objectives. Understand the concept of object-oriented, discuss about traditional application, describe the object structure and object classes, understand the multiple inheritances, and explain the application of persistent programming language. Object-oriented database provides all the facilities associated with object-oriented paradigm. It enables us to create classes, organize objects, structure an inheritance hierarchy, and call methods of other classes. Besides these, it also provides the facilities associated with standard database systems. However, object-oriented database systems have not yet replaced the OODBMS in commercial business applications. Object-oriented database enables to represent the information in the form of objects. With the database management principles and object-oriented programming capabilities forms an object-oriented database management system, OODBMS. Object-oriented database bridges the data modeling and programming in an object-oriented environment, thereby averting the object-relational impedance mismatch. Object database permits developers to model complex data easily and capture the relationships in a natural way. New database applications. Just have a look on some new database applications, which are traditional applications, 4 generations of traditional DB systems, file system, hierarchical, codacil, and relational. All are designed for business applications: inventory, employee, university, bank, library, airline reservation systems, etc. Common features of traditional applications: uniformity, large number of similarly structured data items, all of which have the same size. Record orientation. The basic data items consist of fixed length records. Small data items. Each record is short. Atomic fields. Fields within a record are short and of fixed length. There is no structure within fields. The first normal form holds. Short transactions within fractions of a second. There is no human interaction with the transaction during its execution. Static conceptual schemes. The database scheme is changed infrequently. Only simple changes are allowed. Example, in relational systems, create relation, remove relation, and add, remove attributes from a relation scheme. New applications. Engineering databases, CAX. Computer-aided design, CAD, manufacturing, CAM, engineering, CAE, CIM, computer-integrated manufacturing. A CAD database stores data required pertaining to an engineering design, including the components of the items being designed, the interrelationship of components, and old versions of designs. Computer-aided software engineering, CASE. A CASE database stores data required to assist software developers, including source code, dependencies among software modules, definitions and uses of variables, and the development history of the software system. Multimedia databases. A multimedia database contains spatial data, audio-video data, and the like. DBs of this sort arise from geophysical data, voicemail systems, and graphics applications. Office Information Systems, OIS. Office automation includes workstation-based tools for document creation and retrieval, tools for maintaining appointment calendars, and so on. An OIS DB must allow queries pertaining to schedules, documents, and contents of documents. Hypertext databases. Hypertext is text enriched with links, that point to other documents. Example, www. Hypertext documents may also be structured in specific ways that help index them. Hypertext database must support the ability to retrieve documents based on links and to query documents based on their structure. Expected features for new applications. Complex objects. A complex object is an item that is viewed as a single object in the real world, but that contains other objects with an arbitrary complex internal structure. Behavioral data. Distinct objects may need to respond in different ways to the same command. For example, the deletion of certain tuples may require deleting other tuples in the case for weak entities. In CAD and case applications, the behavior of different objects in response to a given command may be widely different. This behavioral information can be captured by storing executable code with objects in the database. Meta-knowledge. General rules about the application rather than specific tuples, that is, data about data, form an important part of expert databases. Long duration transactions. CAD and case applications involve human interaction with the data. What if modifications that the user may wish to undo, concurrent designer efforts that may lead to conflicts among transactions. Important concepts: nested transactions, correct, non-serializable executions. Object-oriented data model. An object-oriented approach to programming is based on the concepts of encapsulation and extensibility. A program in general consists of data and code that operates on the data. Object-oriented programming encapsulates in an object some data and programs to operate on the data. The data is the state of the object and the code is the behavior of the object. The state of an object is the set of values of the attributes defined for the object, and the behavior is a set of methods with a well-defined interface for their invocation. Object-oriented programming requires the invocation of the behavior of an object via message passing to the object through the interface defined for the behavior of the object. Extensibility refers to the ability to extend an existing system without introducing changes to it. Extensibility is an especially powerful concept for building and evolving very large and complex software systems. A data model is a logical organization of the real-world objects, entities, constraints on them, and relationships among objects. A data model that captures object-oriented concepts is an object-oriented data model. Object and object identifier. Any real-world entity is uniformly modeled as an object associated with a unique ID used to pinpoint an object to retrieve. Attributes and methods. Every object has a state, the set of values for the attributes of the objects, and a behavior, the set of methods, program code, which operate on the state of the object. Class. A means of grouping all the objects which share the same set of attributes and methods. An object must belong to only one class as an instance of that class, instance of relationship. Class hierarchy and inheritance. Derive a new class, subclass, from an existing class, superclass. The subclass inherits all the attributes and methods of the existing class and may have additional attributes and methods. The object-oriented paradigm is based on encapsulating code and data into a single unit. Conceptually, all interactions between an object and the rest of the system are via messages. In general, an object has associated with it a set of variables that contain the data for the object. The value of each variable is itself an object. A set of message to which the object responds. Motivation of using messages and methods. Usually there are many similar objects in a DB. By similar, it means that they respond to the same messages, use the same methods, and have variables of the same name and type. The definition of the class employee written in pseudocode. The definition shows the variables and the messages to which the objects of the class respond, but not the methods that handle the messages. Class captures the instance of relationship, the basis on which a query may be formulated, enhance the integrity of OO systems by introducing type checking, and reducing replications of names and integrity related specifications among objects in the same class. An object-oriented database schema typically requires a large number of classes. Often, however, several classes are similar. For example, bank employees are similar to customers. In order to allow the direct representation of similarities among classes, we need to place classes in a specialization hierarchy. Example, figure is a specialization hierarchy for the ER model. Multiple inheritance is a feature of some object-oriented computer programming languages. In most cases, tree-structured organization of classes is adequate to describe applications. In such cases, all superclasses of a class are ancestors of descendants of another in the hierarchy. However, there are situations that cannot be represented well in a tree-structured class hierarchy. An object retains its identity even if some or all of the values of variables or definitions of methods change over time. This concept of object identity is necessary in applications but do not apply to tuples of a relational database. Object identity is a stronger notion of identity than typically found in programming languages or in data models not based on object orientation. Several forms of identity. Value. A data value is used for identity. Example, the primary key of a tuple in a relational database. Name. A user-supplied name is used for identity. Example, file name in a file system. Built-in. A notion of identity is built into the data model or programming languages and no user-supplied identifier is required. Example, in OO systems. Objects that contain other objects are called complex or composite objects. There can be multiple levels of containment forming a containment hierarchy among objects. Example, a bicycle design database. Containment allows data to be viewed at different granularities by different users. Example, wheel by wheel designer but bicycle by a salesperson. The containment hierarchy is used to find all objects contained in a bicycle object. The expression of object orientation can be done in one of the two ways. The concepts of object orientation can be used purely as a design tool and are encoded into, example, a relational database. Example, ER modeling. The concepts of object orientation are incorporated into a language that is used to manipulate the database. There are several possible languages into which the concepts can be integrated. Persistent programming languages. Data that continue to exist even after the program that created it has terminated. In a persistent program language, query language is fully integrated with the host language and both share the same type system. Any format changes required in databases are carried out transparently. Using embedded SQL, a programmer is responsible for writing explicit code to fetch data into memory or store data back to the database. In a persistent program language, a programmer can manipulate persistent data without having to write such code explicitly. Persistence by class. Declare class to be persistent. All objects of the class are then persistent objects. Simple, not flexible, since it is often useful to have both transient and persistent objects in a single class. In many OODB systems, declaring a class to be persistent is interpreted as persistible. Objects in the class potentially can be made persistent. Persistence by creation. Introduce new syntax to create persistent objects. Persistence by marking. Mark an object persistent after it is created and before the program terminates. Persistence by reference. One or more objects are explicitly declared as root persistent objects. All other objects are persistent if they are referred directly or indirectly from a root persistent object. The association of an object with a physical location in storage, as in C++, may change over time. There are several degrees of permanence of identity. Intra-procedure. Identity persists only during the execution of a single procedure. Example, local variables within procedures. Intra-program. Identity persists only during the execution of a single program or query. Example, global variables in programming languages and main memory or virtual memory pointers. Inter-program. Identity persists from one program execution to another. Example, pointers to file system data on disk, but may change if the way data is stored in the file system is changed. Persistent. Identity persists not only among program executions, but also among structural reorganizations of the data. This is the persistent form of identity required for object-oriented systems. Code that implements methods should be stored in the database as part of the schema along with type definitions, but many implementations store them outside of the database to avoid having to integrate system software such as compilers with the database system. Give names to objects like we give names to files. Works only for small sets of objects. Expose object identifiers or persistent pointers to the objects. Store the collections of objects and allow programs to iterate over the collections to find required objects. Persistent C++ systems. The first issue from a programming language perspective regarding the integration of database facilities concerns the handling of persistent entities or values. The ODMG, Object Database Management Group, has been working on standardizing language extensions to C++ and Smalltalk to support persistence, and on defining class libraries to support persistence. There are two parts to the ODMG C++ extension: the C++ Object Definition Language, C++ ODL, and the C++ Object Manipulation Language, C++ OML. An example: the ODMG C++ Object Definition Language is in figure. Person and account are subclasses of persistence. Object and objects in these classes can therefore be made persistent. Customer is a subclass of person and is thus also a subclass of persistence object. Methods can be directly invoked and behave like procedure calls. The keyword private indicates that the following attributes or methods are visible to only methods of the class. Public indicates that the attributes or methods are visible to other code as well. Type ref branch is a reference or persistent pointer to an object of type branch. Referential integrity constraint is specified using inverse. Template class D, ref Class used to specify references, persistent pointers. Template class D, set class used to define sets of objects. Methods include insert element E and delete element E. Other collection classes such as D bag, set with duplicates allowed, D list and DV array, variable length array also provided. Relationships between classes implemented by references. Special reference types enforces integrity by adding, removing inverse links. Type D, REL, REF class, INV, REF is a reference to class where attribute INV, REF of class is the inverse reference. Similarly, D, REL, set, class, INV, REF is used for a set of references. Assignment method of class D, REL, REF is overloaded. Uses persistent versions of C++ operators such as new DB, DREF account, account is equal to new, bank DB account, account. New allocates the object in the specified database rather than in memory. The second argument, account, gives type name used in the database. Constructor for a class, a special method to initialize objects when they are created, called automatically on new call. Class extends maintained automatically on object creation and deletion. Class D database provides methods to open a database, open database name, give names to objects, set object name, object name, look up objects by name, look up object name, rename objects, rename object, old name, new name, close a database, close. Class D object is inherited by all persistent classes, provides methods to allocate and delete objects. Method mark modified must be called before an object is updated, is automatically called when object is created. Summary. Now in the end, let us summarize what we have learnt in this lecture. Object-oriented database provides all the facilities associated with object-oriented paradigm. It enables us to create classes, organize objects, structure an inheritance hierarchy, and call methods of other classes. In most cases, tree-structured organization of classes is adequate to describe applications. In such cases, all superclasses of a class are ancestors of descendants of another in the hierarchy. However, there are situations that cannot be represented well in a tree-structured class hierarchy. Code should be stored in the database as part of the schema along with type definitions, but many implementations store them outside of the database to avoid having to integrate system software such as compilers with the database system. In a persistent program language, a programmer can manipulate persistent data without having to write such code explicitly. One or more objects are explicitly declared as root persistent objects. All other objects are persistent if they are referred directly or indirectly from a root persistent object.